So first of all, am I audible?
Yes.
And my screen is also visible, right?
Yes.
Okay, so this is the first problem of Division 2 Code Forces, today's Code Forces round. And in this problem, we are given the number of problems that Om and Addy solved on ith day. And we have to find which of those had the maximum streak. Yeah, the session is being recorded. Okay, so for this, like this is just an implementation problem. You don't have to apply any logic, but how to implement this? Suppose we have an array A. So if let's say current element is E, we'll simply check if E is more than, let's say, 0. We'll increment another variable. Let's call it either C or maybe count. So we simply increment this. And if in case E is equals to 0, then we have another value. Let's say for Om it was X. So we'll take X equals to maximum of X comma count. So this way we'll get the maximum streak in X for Om. So is this clear? Is the approach clear?
Yes.
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 Okay, so let's look at the implementation. Okay, so this is the implementation. In this, first I have taken my array A and B as input. Then X corresponds to the maximum streak for array A that I can get, and Y is the maximum streak for array B. So currently my count, like initially count is equals to 0, and each time I'm getting an element which is more than 0, I'm incrementing my C. And if my element is 0, I'll simply reinitialize my C to 0. Then for each of the elements, I'm taking the maximum of C, and if it's more than X, I'll initialize my X equals to C. And I'm doing the same for array B also. So finally, I'm checking if X is more than Y, I'll output Om. Otherwise, if X is equals to Y, I'll output draw. And if X is less than Y, I'll output addy. So is this clear to everyone, or anyone is having any doubt?
No.
Okay, so let's move to the,
Sir, we can do that in one loop only, right? Checking
yeah, you can do
maximum.
that in one loop also.
Okay, sir.
Okay, so let's move to the second problem. So this is the second problem. In this problem, we are given an array A and an integer B, and we have to find whether there exists a non-empty subsequence A such that the bitwise AND of all the elements in the subsequence is equals to B. So how many of you were able to solve this problem during the contest? Like, okay. Okay. So like many were able to do this. So in this problem, let's discuss it here. So in this problem, let's say we have an array A and we have some elements, right? So using these elements, like some of these elements, we need to take some of these elements and have, let's say we selected AI, AJ, AK, and finally the AND of these AI, AJ, and AK. Maybe like right now I'm selecting 3 elements, but it's not mandatory to select 3. You can have 1 element, 2 element, 3, anyway. But make sure that you are having at least 1 element. Like you cannot have an empty subsequence. So you should have a non-empty sequence. and you can have any number of selected values from 1 to n. And after all those selected values, you do an AND operation on all those values. The final value should be equals to b. So is the problem statement clear to everyone?
Yes, sir.
Yes, sir.
Okay. So now see which element will I select if this element has a bit closed. Suppose let's say the fourth bit is closed in my AI and it's open in B. So is it beneficial? Is it ever going to help me choosing this element AI if it had fourth bit closed and my fourth bit was on in 1? Like from fourth bit was on or set in B. So I'll never select this AI, right? This element. Why? Because if I perform this AND operation, finally my fourth bit will be closed anyways. So I'll only select those. Is this clear? Am I making sense why I won't select this AI? Okay, try to, if you have something, try to unmute yourself and let me know, because sometimes I might just skip whatever you're writing in chat. Okay. So, okay, somebody said that I needed to repeat this. See, if my fourth bit, I'm just taking an example for fourth bit. Let's say my fourth bit was closed. This is the representation. This is my 0th bit, first bit, second bit, third bit, and this is my fourth bit, right? So let's say this is my B. This is my B. Okay. This is this value is my B. This is the binary representation of B. And now, is it ever going to benefit me if I have a value A which has 0 at fourth place? And there are some, maybe let's say there are some 1 0 following this. So is it ever going to help me if there is a bit which is set in B and it's closed in this ith element AI? This is the binary representation of AI. So this is never beneficial for me. Why? Because finally, since I have to perform AND operations, if I choose this element, my final fourth bit is always going to be unset.
Yes.
Okay. So now I'll only select those elements which have all those bits open in them, for which the bits are open in B. So now, among those elements, how to select further? Now it's beneficial for us to select all those elements. Why? Because see, now I have got something maybe 1 1 1, and now I make sure that all these bits are open in B, but there are some bits closed in B which I have to close, right? All the bits that are open in B, I have got all those bits open in my final value, but now I want to close some bits which are also closed in B. So for that, I should have maximum elements. Why? Because all those elements are anyway having their bits that are open in B. Those have open their bits. The bits are open in those elements. So select all the elements whose AI and B is equals to B. This is nothing but these are those elements which have their bits. All these bits are open, all the bits that are open in B are open in AI also. Other bits can also be open in AI, but at least those bits will be open in AI which are open in B if AI and B is equals to B. So is this clear?
Yes.
Yes, sir.
Okay. So simply check for all the numbers, include that to your answer for which AI and B is equals to 0. Then finally check if the number of selected, if you have at least selected one number and the final value that you are getting is equals to B. If any of both of these conditions are satisfied, your answer is yes, otherwise your answer is no. So shall we move to the implementation?
Yes.
Sir, can you repeat what you said just now, last sentence?
Okay, just check for once you do this, you'll get all the AIs to select. If AI is and B is equals to B, you can select this element. So finally, for all of these selected elements, if the AND value of all the selected elements is equals to B and you are selecting at least one element, you cannot have non-empty, right?
Yes.
Yes, sir.
Then answer will be yes, otherwise the answer will be no.
Okay, sir, got it.
And is my voice breaking? Like, is there any lag in the audio or the video?
No, sir, no, sir.
No. Okay. So let's move to the implementation. So this is the implementation. Okay is basically, okay will give me whether or not I have selected at least one element till now. So initially, since I have the maximum element in my array and the maximum limit for B is 2 to the power 30 minus 1. So this is 2 to the power 30 minus 1. So all the bits are currently all the 30, like 0 to 29. All these bits I'm currently setting as 1 in X. And then if E and B is equals to B, that means for the current element, all the bits are open that are open in B. So if this is true, I'll perform this AND operation of E with X. This is my final value. And since I have taken at least one element now, my OK is 1. So finally, I'm checking if the final value is equals to B and I have at least selected one element. My answer is yes, otherwise my answer is no. Now, this can be implemented in many ways. Like you don't have to do it this way, like I'm doing it. You can first select, like first have the indices of the elements for which this is true and then have the AND value, then calculate the AND value.
So can you repeat what you have done on the line 120?
Like 120 is nothing but 2 to the power 30 minus 1.
No, sir, that left shift.
Yeah, this is 2 to the power 30 minus 1.
Okay.
Okay, so okay, so let's move to the next problem.
What? Sir, can you go back? I have one doubt.
Okay,
Sir, X and equal to E, what is the implementation?
this is nothing but you are doing X and E and storing in X.
No, sir. What is the use of that?
Like for a final value, like for all the selected elements, after like you need to check, right? For all the selected elements, their AND value should be, if you apply AND operation in each of those values, A1, like you selected I, J, K elements. So AI and AJ and AK should be equals to B, right? So for that, I'm using X. X will have the final AND value of all the selected elements.
So
but
can
why
we do
are
like,
we using it with 2 to the power 30 minus 1?
Because initially I'm setting on all the bits as 1.
Oh, okay, got it. Sir.
next?
Okay. I think like probably like some people are feeling like we are going too slow, right? Okay, anyways. So this is the third problem. In this problem, so we have a string S and our task. Okay, so we are given a string S and what we have to do that we have some vowels and we need to find in how many ways we can slice this string such that each piece, after we slice this string, each piece will have exactly k vowels. So how many of you were able to solve this problem? Like you can raise your hand simply. Okay. And how many felt that this problem was easier than the last problem? Okay, yeah, some felt that this problem was easier than the last one, right? Okay. Anyway, so let's look at.
I was not able to solve the last problem, but I did this one.
Okay. Okay. So let's look at. This is just a simple. I think this is nothing but a simple maths like you have to just compute. So this is a simple maths problem. You don't have any observation or you don't require any knowledge of algorithms to solve this problem. So we are given that we have a string S and it has some vowels in it. And finally, if we slice this string into some parts, so how many ways are there to slice this string such that after slicing, each part will have at least like at exactly k vowels, right? So let's say this is our string. There is a vowel. Okay, so there is a vowel present here, here, and here, and currently my k is equals to 1. So one thing is for sure, like you'll have, like now I'm marking my boundaries. So let's say the first piece will have its left boundary here only. Do you have any option other than this for your left boundary for the first piece? No, right? And for the second piece, you can, like for the first piece is ending, for the second piece is starting. You can either have your boundary here. This is your first option and this is your second option. If my k is 1, right? Why you have two options? Because you cannot have your right boundary here, then your first piece won't have any vowels. You cannot have your boundary here, then your first piece will have two vowels. So you have two options, right?
Yes.
And similarly, if some like vowel was present here, then you had 1, 2, 3, 4 options. So what I'm doing here, simply, if you have like just count at what positions you have your k vowels completed, like when you have found your k vowels in for the current piece, then between this vowel and the next vowel, suppose there are count characters, simply multiply your answer into like whatever the answer you had till now, simply multiply it with answer into is equals to count plus 1. Why plus 1? Because if you have 3 characters, then you have 4 options for your boundary. If you had only 1 character, you had 2 options. If you had 0 characters, like this is a 1 vowel, you had k vowels still here. Now there is another vowel here. So you have only 1 option, right? You have to choose your boundary like this. So multiply your count plus 1, answer with count plus 1. So is this clear? Or is anyone still having any doubt?
Hello.
Yes.
In place of count plus 1, we can do the difference between two indices.
Yep. Yeah, the difference between the two indices of your like vowels. So is it clear?
Yes.
Yes,
Okay,
sir.
so let's move to the implementation part. Okay. So for this, I've taken my string as input, and then for each of the characters, if my current character is a vowel, I'm incrementing my count, and if my count is finally equals to k plus 1, that means for the current piece, I have finally got my first like the k vowels, and now this vowel is for the next piece. So what I'm doing, I'm simply doing like count is now equals to 1, and my answer is finally like I don't think I actually need count here. Like it's not being used anyway. Like I have done the same thing using x, so I don't actually think I require this count variable. Yep, I have declared it, but I'm not using it 4 times, right? 1, 2, 3. Am I using this count 1, 2, 3? Like it said that it's, yeah, I'm not using it, I don't think. Yep. So what I'm trying to do, so x is basically the number of characters that have appeared between the last vowel and the current vowel. So I'm multiplying my answer with x plus 1, and now I'm again initializing my x is 0 for each for each vowel, my now X is 0. Otherwise, if none of these, like my current character was none of these, that is, it wasn't a vowel. So then I'll simply increment my X. And each time I get a vowel, okay, I'm using count here, right? So each time I get a vowel, I'll increment my count. And if my count is equals to k plus 1, that means now I have my k vowels for the last piece. And now then this vowel, the current vowel, is for the next piece. So my count will be equals to 1. And I'll simply, like, why is count equals to 1? Because I have got one vowel for the next piece also, right? So I won't initialize my count as 0 here. That's why count is equals to 1. And then my answer will be multiplied by X plus 1. I have X characters between my last and current character, and finally multiply it with X plus 1 options, my answer, and finally output answer. So is this clear to everyone?
This for auto loop is similar to for loop.
Yes, this is similar to for loop. Like actually, you should try to focus more on the on the approach rather than the implementation.
So what we are trying to do in the line number 134, the counting part, I'm not able to get this. Can you repeat?
Like answer multiplied by the number of options that you have for choosing a boundary between the last vowel and the current vowel. So if you had X characters in between, you have X plus 1 options for choosing a boundary.
Okay.
So this is clear to everyone, right?
Yes.
Okay. So let's move to the next problem. Okay. So how many people were able to do this problem? Okay, is there anyone, like, you can raise your hand if there is anyone who was able to do this problem during the contest. Okay, so this problem, like, I think there is a better solution than mine. I solved it using some maths formulas, but I think there is a better. But let me explain my solution. It's not that, like, it's more intuitive. My solution is more intuitive, but it requires more computation. See, in this problem, we have a string which has either a character 4 or a character 0 or a star. Now we can remove these stars with either a 4 or a 0, and we have to tell for all these strings that we'll get after replacing these stars, all these stars, how many, for like all those strings, what are the count of 404 that we'll get as a subsequence, not as a substring. Like it's not necessary that these all like 3 characters should appear next to each other, like concurrently. It's possible that I have 4 4 4 0 4 0 4. So I can select this 4, this, and this like this 0, this 4, and this 4. So this will count as one of the 404s that I'm getting as a subsequence. So now, okay, there is a lag. Someone said that there is a lag.
No, sir, I don't have any lag.
Okay, so probably you are facing, like, whoever wrote this lag and chat, probably you're facing into some internet issues. So, okay, now the problem statement is clear, right? I have a string S and I have to replace all of these stars with either a character 4 or a 0. And finally, for all the strings that I'll get, I have to count that how many times 404 I'm getting as a substring, not as a subsequence. So this is clear, right?
Yes.
Okay. So now see, first of all, I have a string. Let's say this is my string. So there are some 404s that are already appearing, right? This is one, and then there is this thing. So these are already appearing. So these will anyway be contributing to all of the strings that you finally get, right? After replacing these stars, these will always be present. Is this making sense?
Yes.
Yes, sir.
So why not count these earlier, and then how many strings there are actually possible? If I have 2 stars, how many strings will I get after?
2
It's
power
2,
2.
2 to the power 2, yeah. So it's 2 to the power count of stars. This is the number of strings. So why not count these values? Let's say these are the, like, since I'm using count star here, let's say I have val as the initial number of count of 404 subsequences in my original string. So why not multiply it by 2 to the power count? Because I am going to get these many because of the initial 404s, right?
Sir,
Is
what
this
is val?
val is the number of 404s in initial, like in this it's 2 initial 404 subsequences that I'm getting in initial string. I'm not
Okay,
using
sir.
count again. This is like, okay. So now I have got all the values that are some characters except star, right? I haven't used star in any way. I am just using these 4 and zeros that are in original string. I have got all the values using these characters that will contribute to my final answer. Now let's suppose, let's use one of these stars. So there is one of these possibilities. If I'm using only one star, there is this possibility. Then there is also one more possibility. This, if I'm using only one star, like I'm using 1 4 from somewhere here, then I'm using another 0, and then I'm using a star. I find somehow, like if I convert this star to 4, then I will get a 404, right? Right?
Yes, sir.
In this, if I replace this star with a 4, I'll get a 404. In this, if I replace this star with a 0, I'll get a 404. So what I'm doing, let's first consider this case, then this case, and then this case. So actually, you don't have to consider these two cases separately, or you can, like, okay, let's come to this a bit later. But for this, what you can do, if there's a star currently, count the number of 4s that appeared before it, count the number of 4s that are going to appear after this, and simply multiply these two counts. That are the number of ways if you replace this star with a 0. Those are the number of 4s. But that is just for one string. Now you have how many strings will you get in total for which this value is selected? It's nothing but 2 to the power count of star minus 1, right? Like the remaining stars are there also, right? So there are two options for all the remaining stars. So 2 to the power count star minus 1 are the total number of strings for which this string you have a 0 here. You have already chosen a character for this, and multiply this by number of count of 4s that appeared previous to this positions into number of count of 4s that are going to appear after this position. So this case is done. Now for this case, simply, okay, let's skip this one right now. Let's see this case 40 star. So for 40 star, what we can do, simply count for each time you get a 4, simply increment your count 4 by 1. Each time you get a 0, increment your count 40. How many times you're going to get 40 now? Plus equals to, if you're getting a 0, if you're getting a 4, if you're getting a 0, simply increment this by count 4.
Minimum.
Because this 0 can be, like, it can be just adjusted in front of any 4 that appeared before this, right? All will give you 40. And now each time you get a star, simply add that 40 count of 40 to your answer, multiplied by again 2 to the power count minus 2, 2 to the count minus 1, because you have used one star. So in this case, your answer is answer plus equals to count of 40. If you get a star, if you get a 4, this is the thing. If you get 0, this is the thing. If you get star, this is count of 40, count of 40 into 2 to the power count star minus 1. So this is what you're going to add. Now,
Can you tell the 2 raised to power count minus
one thing, like why we are multiplying with this. What are you asking me? 2 raised to power count minus 1. Why we are multiplying with this? Because see, you have total number of strings. In this problem, you are required to find all the 404s in all the strings that you can get after replacing this. So if you have count star number of stars in your string, 2 to the power count star strings are possible. But since you have used up one star here, so therefore 2 to the power count star minus 1 number of strings are possible now. So that's why this is getting multiplied.
But these stars should after be the 0.
Like, okay, for those I'll be like, what if there are no stars here? You're saying this.
No, the stars before the 4 are why they're counted, because they will.
Because if you choose 4 here or 0 here, both will be different strings, right? And in both these strings, if you had a 4 here, this 404 would have came in both of these strings. So that's why this needs to be multiplied.
Yes.
Okay. So now I'm done for 40 and there was a star. So just reverse your string and do the same thing. Just reverse your string and you'll get the value for star 04. Right? There's no need to calculate again. Now let's assume that I'm using 2 stars. So using 2 stars, either I'll do something like 04, like 404 like this, or like this, or maybe let's say this. These are the ways of using 2 stars, right? So for this, I have to do the same thing. For this, what I'll do, how many number of ways? Suppose I get a 0. So find, okay, how many stars appeared before, how many stars appeared afterwards, count of stars that appeared before. Let's call it count star B into count star afterwards. Let's call it A into 2 to the power count minus 2. Why? Because I've used 2 stars, count of stars. This is total count. Count star is nothing but total number of stars that I'm getting in my string. 2 to the power count of star minus 2. So this will, for this case, this value will get added to my answer. For this case, each time you get a 4, just multiply. Suppose you have count star B is how many stars have you got before this position. So you will multiply count star B into count star B minus 1 by 2. What is this? Number of ways to choose 2 stars from count star B. Like, what is NC2? NC2 is nothing but n into n plus 1 and into n minus 1 by 2, right? Number of combinations that you can get, like for selecting 2 items from given n items. So basically this is count B C2, count star B C2. So you will add this thing to your answer plus count B, count star B that appeared before into count star B minus 1 by 2 into 2 to the power count star, that is total number of stars that you're getting minus 2, because 2 stars have been used here. So now I have got this thing computed, right? Simply reverse your string and do the same thing and you'll get the answer for this thing. Now there is only one case left when you are using 3 stars. So when you're using 3 stars, how many 404s you can get? First of all, number of ways of selecting 3 stars is NC, like count star C3. C3. This is nothing but like NC3 is, what is NC3? N into n minus 1 into n minus 2 divided by 6, right?
Yes.
Using this formula, calculate this value and multiply this by 2 to the power count star minus 3 and add it to your answer. Why 2 to the power count? Because I have used 3 stars and now these many strings are further possible. If I had some value selected for this string, and what is the value for these 3? It is nothing but 404. Like these 3 positions will be finalized. And other than that, if some other stars were there, they will further make these many more strings. So just add this to your answer. Now you might feel that this is very cumbersome and like it's difficult to implement, but if you had just coded one of the cases above, the rest are just copy paste. Yeah. So, but definitely there is a better solution for this problem than this thing. I don't think that the solution that I've discussed, this was like, this is the actually meant solution for this. But during the contest, this was what I came up with. So let me share the implementation also.
Can there be DP solution?
Like I'm not going to discuss this. Yes, there is a DP solution also, but I'm not going to discuss this right now. If you have, like, you can raise a query and probably tag me or other mentors, and someone will look into it. Okay.
Yes.
Okay. So this is the implementation. First, I'm taking n as input, then I'm taking string s as input. Finally, C is the number of stars that I have. This is count of stars. Then in power, I'm calculating 2 to the power C minus 1. This is like, remember that this is, I'm not calculating 2 to the power C, but I'm calculating 2 to the power C minus 1. So now this is the values of fours, like number of 404s that I'm getting in my initial string. Then I didn't change any stars. So these are the values. Finally, if I had more than one star, more than one or one star, I'll simply multiply my 2 to the power number of stars, 2 to the power count stars with my answer, whichever I calculated from, like whatever value I got from this. Then there are those 7, or maybe let's say, like for considering like removing that last case when all 3 are stars, there are 6 cases left. So this is the case when I have 4 star 4. So C4 is the number of 4s that I have before this position, that I have achieved like or got before this index. C4S is the number of 4s that I have got that I'll get after this position. So simply multiplied those two things. Power was nothing but 2 to the power count of stars minus 1, right?
Yes.
So then multiplied x into power and simply take it mod and add to your answer. Now, similarly, I have just copy pasted it and made minor changes. That now for 4, 0 and star, what I'm doing for 4, 0 and star, simply add how many times you are getting 4, 0 before. If currently I'm getting a star, just add number of times you're getting 4 zeros before 4 zeros as a subsequence, not like exactly 4 0 next to each other, but 4 0 as a subsequence, and multiply that with 2 to the power count of stars minus 1. Now the next case is 4, like this was 4 0 star, now it's star 0 4. So for that, simply reverse this string, do the same thing, and finally reverse the string back to its original, right? Then it's having 2 stars, something like star 4, star 0 and 4. So for that, simply check how many stars appeared before this. If I have a 0 right now, simply check how many stars appeared before this, how many stars are going to appear after this. And now power is 2 to the power, what was C? C was number of stars that I have. So 2 to the power count of stars minus 2. So multiply your x with it, finally add the value to your answer. Now this case is 4 star star. So for 4 star star, just no, this is star star 4. So star star 4 for CS count of stars that you have got till now multiplied by CS minus 1. This is nothing but CS count of stars C2, and multiply this value with power. Power is nothing but 2 to the power count of total number of stars minus 2. Then again, you have computed your value for star star 4. So now you have to calculate for 4 star star. So for doing that, just reverse your string, do the same thing again, and add your value to your answer and reverse your string back to its original value, whatever it was initially. Now the case when you have to compute, when you are using 3 stars. So this is nothing but 2 to the power count 3, like count of stars minus 3. Then for calculating NC3, I'm doing this. but you don't actually have to do this. If you do, like if you adjust your modulo or if you take inverse of 6 under modulo, then you don't have to do this. But it's pretty simple, right? It's calculating NC6, NC3.
Yes.
Okay. Finally, add everything to your answer, and finally you can print it. So is this clear? Yes, no, anyone?
Yes.
Okay, so let's look at the next problem. So this is the next problem. In this problem, we given a matrix of n rows and m columns, and our task is to choose a I comma jth element from this matrix such that if, okay, let me describe this here. Okay, was anyone able to do this problem during the contest? Okay, so suppose this is our matrix and I chose, let's say, this element. So all the elements that are not part of this row and this column, what you have to do for all of the remaining elements that are these elements, right? For all of these elements, you have to take their XOR with this element and add and like find the total sum. So whatever is the maximum for all the elements of ij, like currently I have chosen this as my current element, right? This element need to be XORed with each of these values, with these green values, this element, and you need to find, considering each of these elements, like each of the elements in the matrix as a this red element, which is being XORed with these green elements, you have to find the maximum value. So is the problem statement clear? What is the maximum that you can get? Is the problem statement clear?
Yes.
Okay. So see, we cannot just brute force this, because then since we have n into m options for our red and like for choosing an element, and then further if we calculate for each value separately, we'll have a n square into m square complexity solution, right? So instead what we'll do, since let's say we'll do the same thing, we'll try to see for each element, but instead of like this is fixed, okay, these are the number of valid options for us to choose element, but instead of checking in n further n into m, we can do this in number of bits, which is 30. How to do this? Like we don't need to actually go through each of the elements. What we can simply do, we can check, okay, how many times among these elements, let's say what is the count of 1 will give me how many times bit 1 is open in all of these elements. No, I'll come to it in a bit how to get this, but is this clear? Like what is count giving me?
No.
Count of 1 is basically number of times bit 1 is open in these elements. So what is the value? Can anyone tell me like what will bit 1 actually contribute? It's nothing but 2 to the power 1 into count 1, right? If I have taken some of these elements, normally I'm not taking any XOR right now, but this is the value, right? This. Now, suppose this first bit was closed in. This first bit was closed in my current AI comma AJ. This is my current AI comma AJ, right? So if this was first bit was closed in my AI comma AJ, then in that case, this value would be added to my value. And otherwise, if my current, like the ith first bit was open in AI comma AJ, then this value won't get, like suppose there are, let's say these are total y elements. Let's say these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These elements. I'm talking about these green elements. Let's say that the count of these green elements is currently y. So if my current bit, this first bit was open in ai comma aj, like ai comma a of I comma j, then like the value that would be contributed will be 2 to the power 1 into y minus count of 1. Is this making sense? Because then all the elements that had it initially, like bits 1 was closed, they'll have it as 1, and all the bits which had my initially that the first bit was open, for them the first bit will get closed, right? That's why like these are the bits if
What is y?
y is the total number of green elements, like removing these ai like all the elements that have appeared in this row and this column. I'm removing these elements, and apart from this the remaining elements are y. Okay.
Yes.
Okay, and count of 1 is basically among these elements how many elements had first bit open in them. So if first bit was open in b, not in b, in ai comma aj. What is ai comma aj? Ai comma aj is this thing, this element which I have currently chosen. So then if the current bit was closed in ai comma aj, then this value, this 2 to the power current, whichever bit it is, into count of current will get contributed to my final value for this ai comma aj. Otherwise, if current bit was open, then after XOR, for all of the elements for which the current bit was closed, it will be opened, and for all the elements for which the current bit was open, it will be closed. So that's why I'm, instead of multiplying my 2 to the power current with count of current, I'm multiplying it with y minus count of current. So y minus count of current is the number of elements which had current bit closed, because count of current is the number of elements that had current bit open. So is this making sense? Is
Yes.
it clear? Okay, it's clear. So my current will go from 0 to 30 for each I comma j, right? So now my complexity is just n into m into 30. Now you just have to make sure you have to do some pre-calculation, like you have to calculate your count array, like you need to pre-calculate it. Secondly, you need one more thing, count of row. How many times in ith row my ith bit will open, right? Otherwise, how will you remove these elements from your, because you need these, right, for each ij. You cannot calculate these for each ij. You'll simply have to calculate for complete and then simply remove this row and this column. So let's move to the, like this will be much more, if the approach is clear, we'll move to the implementation, because the implementation will be much more clear when you actually see the code. Otherwise, I'll just keep writing some math stuff here, and everything like will go in vain. So if the
But-
approach is clear, we'll move to the implementation. Yes, someone was saying something.
But n and m both are 10 to the power 5.
No, both are not n into m. Like I'm pretty sure like n and m both cannot go till 10 to the power 5. N into m is up till 10 to the power 6 only.
Okay.
Yeah, if n and m are both going till 10 to the power 5, then practically you cannot take input as well, because there will be 10 to, like the size of the grid will be 10 to the power 10.
Yes.
Okay, so let's look at the implementation. So I have my vector like A as my grid. I'm taking input, and then this row is basically the number. For each row I have, like row is nothing but it's a vector of size n comma n into 30, or it's an array of size n into 30. So for each row, let's say for each row from 1 to 30, I'll have the count, like how many times jth bit is open in ith row. So that is given me by row I comma j. But let's call it row I comma b. for ith row, how many elements bth bit is open. Same for columns. Column of I comma b will give me how many elements had bth bit open in ith column. And finally count. Count is nothing but for all the grid, count I is number of elements that have ith bit open in them. So what I'm doing, I'm iterating over my grid, I'm calculating this count values, then I'm again iterating over my grid, and if this current bit, like first of all, I'm trying to get like this, making it this temp vector, and where this temp vector will be used, this temp vector is basically those green elements, those elements that are not part of current row and current column. So for that, what I'm doing for calculating the number of bits that are open in those elements that are not part of current row and current column. So from all the grid, I'm removing current row, current column, and since there is an element that appears in both current row and current column, that is this I comma jth element, right? So I would have subtracted it twice. For all the elements, I am subtracting only once. For the current element, I have subtracted it twice. Is this clear? Why I would have subtracted it twice? Yes, no, anyway. Okay. So in case if the current, like the bit is open for the current I comma jth element, I would have subtracted it twice. So I'm simply adding one if the current bit is open. Like the bth bit is open in a comma aj. ai comma not ai comma aj, a of I comma j. If this bit was open in a of I comma j, I'm simply adding one, because in that case I would have subtracted it twice. Then once I have my temp array or temp vector, then again I'm iterating over all the bits, and if the current bit is open in, if the current bit is closed in a of I comma j, I'll simply add this value, that is nothing but count of number of times bth bit is open in the elements apart from the current row and current column into 2 to the power current bit. And otherwise, these are the total number of elements n into m subtracted by the current row elements, current column elements plus 1. So these are the number of green elements that I showed you, minus temp of b is the number of elements that have the bth bit open. So this is number of elements that don't have the bth bit open, and finally multiplied by 2 to the power b. So then this is the value that, like, once you have calculated the value, simply take the maximum, and like answer is equals to maximum of answer comma the value that you have calculated right now, and then print your answer. So is this clear to everyone?
Yes.
The approach is clear, right?
Yes.
You can implement it in like different ways also, but the like approach, that how to get your solution from n into m into again n into m to n into m into 30. So this is clear, right? If this is clear, like you'll be able to implement it yourself. Okay, give me a yes or no. Is this clear?
Yes.
Okay, so let's move to the next problem. Okay, so in this problem, we're given an array A of n integers, and rank is basically defined as, for the ith index element, rank is the number of elements that are, okay, is my screen lagging or is my voice breaking right
No.
now? Okay. If, and like in any case, if you feel like, okay, someone's like some people facing this issue, right? But yeah, if in any case, if like it gets like a little more worse, or like it's not you're not able to understand what I'm saying, just let me know. Okay, if you feel like you cannot understand what I'm trying to say. Okay, so in this problem, you're given an array A of n integers, and the rank of an element at index I is defined as the number of elements in array A which are more than current element, like the ith element plus 1. So that way rank of current element is defined. So finally you are given q queries k, and for the k, like ith query, you are given two integers k and r, and you have to find the minimum number of elements x that you'll remove from the front of kth element. Like k is one index and the array is also one index. So the number of elements that you'll remove from the subarray a of 1 to k minus 1, and the same number of x elements you'll remove from a of k plus 1 to n, such that now the rank of current element should be smaller than or equals to r. That means now the elements that are more than or equals to, like strict, like the elements that are more than a of k are less than r. Is this clear? Is the problem statement clear?
Yes.
Okay, so let's say you had something like this and your current k is this. So you can, from these subarrays, so answer is always possible, right? R is, because R can be minimum equals to 1, and if you remove all of these elements and all of these elements, in any case you'll have no element more than k. So in that case your rank will be 1 only. So this is clear that answer is always possible in any case. It's never, like, you'll never have a case that you don't have an answer. Like, it's not possible to get this element's rank equals to r. It's never possible. Like, it's always possible to remove all the elements from left side and right side. Basically those subarrays are nothing but all the elements on the left side and all the elements on the right side, those subarrays. So now, like, I have solved this problem using ordered set. So what is ordered set? You can actually implement this data structure. Like, it's not that advanced. If you know some things about do you know set?
Yes.
So how is set actually implemented in C++? It is implemented using red black tree.
Yes.
So ordered set is similar to set, but also it gives you the element. Suppose it gives you it, like, set just only stores only unique values, and it stores them in increasing for order, right?
Yes.
Similarly, multiset stores only in increasing order, not unique values. So I have used ordered multiset. So ordered multiset will also gives you for each, like, I can ask it, like, okay, what is the number of elements that are more than this, or maybe what are the elements less than this, and how you can actually implement this using, if you know ABL trees, like, yeah,
Yes,
something.
self-balanced.
Okay, maybe you can implement this using AVL trees or red black trees. How basically AVL and red black trees are nothing but they are self-balancing trees. So apart from just, like, in a conventional tree, you just have a node value, and a left pointer and a right pointer, right? So apart from these, if you have a binary, like in binary search tree, you have nothing. These are nothing but these are self-balancing trees, these AVL and red black. So at any node, the value of the left, like the maximum depth of any left node or any right node for these trees, it's like the difference is at max 1. The difference between the depths of any leaf node from this, any two leaf nodes from this node for each node. So this is because, so in order to maintain the complexity, always O of log n, because if it's skewed, then your complexity will go to O of n. So in conventional trees, these are the three values that are stored for each node. In case of these, if you want to implement these, you'll just have a fourth something like index. And in binary search tree, what is the case? Like if this is X, this value will be probably left will be less than X. Like this value, let's say this is some Y, this will be less than X, less than or equals to X, and this side, if it's, let's say Z, Z will be more than X, right? So you can just also have, or instead of this, just have the number of, like the size, left size or right size, how many elements are belong to this subtree. So that way you can actually implement this order multiset. But I have used it with, like, it's predefined in C++ also. But in other languages, I don't think it is. Like, I'm also not sure, and I haven't used it for other languages. So what I have done, like if I simply get, okay, how many elements are less than my current element in this range and in this range, then I can simply use binary search, right? If I have given, I'm currently given my R, and if I have a value R given to me, I'll simply first try to remove 3 elements from here, 3 elements from here, and check, okay. And by the way, which 3 elements will I remove? I'll always remove the maximum ones, right? There's no point removing one if I have a 10 here. Because anyway, if this value is 100, it's good. If this value is 5, there was no point in removing this one. This was already less than my 5. So if I want to decrease my 5's, like this element's rank, I should have removed 10. Is this making sense?
Yes.
Okay. So basically my binary search for, if I'm checking for X, I'll simply, like if X is 3, I'll remove my 3 elements from this side. I'll remove 3 elements from this side, and I'll simply check whether or not after doing this current elements, the max, like number of elements that are more than my current element, are they more than or not, like more or less than the current number of elements that are more than my current element, are they less than or equals to R or not? If they are less than equals to R, then my current element's rank is possible. Like I can make my current element's rank equals to R. So that way I'll do binary search. So now only one thing is left. That is, if I had this array, since I'm using another data structure, I'll move from this direction to this direction, right? But my queries are random. Like for this, I have some K1, R1, then I have K2, R2 here, and then I have K3, R3. So if you need, you cannot jump from here to here, right? Because you have these elements in your another data structure, then you need to have these elements, then you need to have these elements. So instead, just sort your queries, all your queries according to their K value, and just process them in order of left to right. That way, your time complexity will be better. Right? Instead of jumping between queries, or all the queries you are jumping, in that case, your worst, like complexity will go to n into k, n into q, where q is the number of queries and n is the number of elements in my array. So instead of jumping between queries, just sort your queries according to k and process your sorted queries, and finally output your answer in the order, like in the order in which queries were given to you. Like this is just an implementation detail. The logic remains the same.
Why sorting is beneficial?
Okay, suppose you had query something like, the first query was your K was this thing and your R was something. So in that case, okay, you can do without this also, like without sorting. But in that case, like, okay, you need only one, like insert at the starting, insert all of these in your that ordered multiset, and then for each of the queries, remove that element currently, and then again, after once you are done with the query, insert it back. So this can be done. But I, like the solution that I have implemented, I have used two ordered multisets. One is for the values that are appearing before, and one is for the values that are appearing afterward. So basically I have my windows like this. So current element is not in any of the two multisets, ordered multisets. and my window will shift like in these direction, both of these, like afterwards it will become like this. So it is not efficient that way. If I, for each query, like first I solved the query which had k here, then another query k was here, then again k came to here. So my, like I'll have to move my windows for like probably in the worst case n times, right, for each query. So that way my complexity would have gone n into q. But yeah, you don't actually require that. You can use only one multiset or ordered multiset. And what you can do, you can at the start, you can insert all these elements in your ordered multiset, and then suppose you have this query k comma r, just remove this element. Once you complete your query, print your answer. In that case, you can print your answer right away and insert this element back. Again, you had this query, again remove this element, perform your calculations. In calculation, what you'll do, you'll from this complete array. But again, okay, I don't think that it's that way, but because we need to remove exactly x elements from left side and x elements from right side, also left side and right side, right? So I don't think that you can solve your problem using one, or maybe you can, but the approach will be more complicated. So simply because you need to erase x elements from left and right side, right? So that's why it's better to maintain two different multisets for left and right side, and try to move these from left to right direction. But for that, you should sort your queries so that your ordered multiset are not like they are not doing like this. Like if for the first query it was like this, then for the second query your multisets changed to this, and for again for the next query it's back to this, and they keep doing again this and this. So for each query you are making n moves or n operations, right? You are removing elements from this multiset and inserting to this, or vice versa. So it's better to sort your queries initially. So is this clear why sorting is required for the queries?
Yes.
Okay, so let's look at the implementation. Okay, this is the implementation. I'm taking n and q as input. Then I'm taking queries as input. Then for sorting queries, I need to know which index they lie, right? So I'm making another vector in this. Since my array is 0 indexed, I'm having k minus 1. This is k, basically the first value is k. Then the second is r, and this is the index. Like this query is for like its ith index query. Then I'm making an ordered multiset, to previous and next. I have sorted my queries and I have my answer vector. So initially I'm inserting each of my values in my next. This next is nothing but my right subarray. Then for each query, like up till current element, I'm inserting each element in my left subarray and I'm removing elements from my right subarray. Then this is possible function for binary search. In binary search, my current answer is current value, like answer for current query is n minus 1. Like if I remove n minus 1, anyway, it's possible for me to achieve any rank. And low is 0 and high is n minus 1. So while low is less than equals to high, I'm taking mid and checking for mid. And if it's possible for mid, my val will be mid and my right boundary will shift to mid minus 1. Otherwise, my left boundary will shift to mid plus 1. So what is happening in possible? I'm like finding, okay, what are the number of elements that are more than current element in left subarray? What are the number of elements that are more than current element in right subarray? Okay, I can remove, this is x. I can remove these number of elements from my right subarray and from my left subarray also. So remove those elements, and if your like these values become negative, take them to be 0. Finally, you need to check, okay, the number of elements that were more in left subarray, number of values that were more in right subarray plus 1. Why plus 1? Because in problem statement, it's stated that rank is L plus 1, not L, where L is the number of elements that are more than AI. So simply check these total number of elements that are more than current element plus 1 is less than equals to R or not. If it's less than equals to R, return true. And finally, the answer for current index. What was index? Index is nothing but after sorting which query this was. So this is answer of index equals to val. So is this clear?
Can we do lower bound in multiset for order of?
Actually, see, it's not that straightforward. Probably you can ask me that in a query, but those functions usually don't work that way in multiset. You cannot erase those elements like that.
Okay.
Okay, so if nobody, we can stop the session. Okay, I think we can stop. Bye.